So we're going to start with the limit as delta x approaches 0. Okay, so I'm going to follow this formula. I'm going to take x plus delta x. I'm going to put it in both of those places. So we'll have a 4 and then x plus delta x, quantity squared, minus 3, plug it in again. So x plus delta x. All right, and then minus the function itself. Now, since my function is more than one term, I'm going to go ahead and add square brackets, so we'll remember to go through and change the sign. Eventually, you may get to the place where you just automatically change the sign initially in that first step, but let's not do that yet. And then all over delta x. Okay, but this limit notation is in front. Now, I'm going to keep working down because I'm going to run out of room here. Okay, so here at the beginning, what do we do just to refresh our memory? We're going to FOIL right here first and then distribute the 4. We'll distribute the 3, and we'll go through and change the signs on that one. All right, so I'm going to keep the 4 literally written out in front for a minute. But the important thing, and the thing that I'm going to look for on your paper, is do you have the limit as delta x approaches 0 in front of this next line? Okay, so we'll have 4. All right, if I'm going to square that, let's see. Square the first term, x squared. 2 times x times delta x. So plus 2x delta x. I'm doing FOIL in my head. All right. And then squaring the delta x. So delta x to the second power. Distributing the 3, minus 3x, minus 3 delta x. Watch me and don't let me make a mistake. And then minus 4x squared plus 3x. All right, everybody agree at that point? Okay, now I will allow you to do this just to save a line, okay, because now some of you might have been able to distribute the 4 at the same time you were foiling, but in the past, people have missed this middle term if they try to FOIL and distribute 4 all at the same time. So to prevent having to write an entire another line, I will let you distribute right above it. So this is going to be a 4x squared plus 8x delta x, and then plus a 4 delta x squared. All right, now at that point then, should we have a bunch of terms that cross out? Yes. Okay, I'm going to let you cross out all in that line as well, so I'm going to start crossing out. I've got a positive 4x squared, I got a minus 4x squared. We have a negative 3x and a positive 3x. Is that about it? I think that's about it, right? So now that I've crossed a bunch out, I'm going to write another line. I'm going to keep the limit notation in front because I haven't taken the limit yet. So the limit as delta x approaches 0. All right, and I'm just going to clean this up. I've got an 8x delta x plus a 4 delta x squared. That's those terms right there. I've got a minus 3 delta x, and then a delta x in the bottom. Okay, everybody agree with me so far? Okay, in the top, I can take out, I can factor out a delta x. So again, I have to keep my limit notation, the limit as delta x approaches 0. Factor out the delta x. So that'll leave me with an 8x plus a 4 delta x minus a 3 delta x on the bottom, which then lets me cross out delta x, delta x. Okay, now I've simplified as far as I can, right? All my algebra on the inside can't do anymore, so now I'm ready to do the direct substitution. When I go to that direct substitution, my limit notation goes away because I'm going to replace delta x with 0. So then that means I'm going to have a delta or a 8x, and then putting 0 in there, I would have a 4 times a 0, which means that's going to fall out, and then minus 3. So then the overall final answer is just the 8x minus 3. But it's at that point where I do that direct substitution, replacing delta x with 0, that the limit notation goes away. And that's the main key. That's the number one main key to this. Limit notation is on every step until you get to the last one, then you remove it. Now, so when it's a polynomial curve like that, not too hard. Okay, we know those algebra steps. We've been doing those algebra steps now for a long time. Okay, but could we do it with a quotient right here? We could, right? Because we also practice the algebra skills of multiplying through by the least common denominator, right? Okay, so let's do one though so that you actually see it. Okay, and we'll do it with a nice simple quotient. Okay, I'm going to start all the way up here so I've got more room. This one has a tendency to take a little bit more room. So let's say our original function was, we'll just go with a 1 over x. 1 over x squared would be harder. 1 over x minus 1 to the second power would be harder. The more complicated this rational expression is, then the more complicated it gets. But again, it's just the algebra. So it's not the calculus that's making this hard. It's the algebra. So what was the formula? Let's see, x plus delta x, difference quotient minus f of x, all over delta x, just so we have something there in the corner to look at. All right, so we're going to replace our x, but see why this is easy? You only have one x in it. I'm replacing it in one spot. Okay, so I start with the limit. Limit as delta x approaches 0. Replace the x with x delta x. So I'm going to have a 1 over x plus delta x. And then minus the function itself, so minus 1 over x. And then all over delta x. So that's just doing the substitution right there. Now, a lot of times, especially when you start creating these complex fractions, it makes sense to maybe do something like that. You're taking the limit of that entire thing, because depending on where you put this limit notation in relationship to the quotient that you've just created, it can get kind of messy. All right, now we know complex fraction, we multiply through by the least common denominator, right? Least common denominator, we look at all the little miniature fractions. So miniature fraction there has that denominator. Miniature fraction right there has that denominator. Do I use anything from the bottom? No, because that bottom would be over 1. So my denominator there is just 1. So that means my least common denominator is x and then x plus delta x. So I've got to multiply the top by that. And again, remember I set that up really, really high from last year so that we remember it's in the numerator so that when we go to distribute that, it's a little bit easier. And then I also have to multiply here on the bottom x and then x plus delta x. Okay, now when we distribute our fractions from here to here should go away, right? If I am multiplying through by the least common denominator, the whole point of doing that is to get rid of my complex fraction here. I must start with that limit as delta x approaches 0. That's what you're going to forget, probably more so than anything. All right, distribute in here. This is in the top. X plus delta x crosses out. You can use the little finger method. You got an x times 1, so x. Fraction goes away. Everybody good with that? Okay, I want to make sure I don't see blank stares. All right, I'm going to bring the minus down. Okay, now I'm going to distribute again, this times this, using the finger method. This x and this x goes away. So I've got 1 times the binomial x plus delta x. It's going to be very important that I keep the parentheses around that binomial because I'm leading it with a minus sign. So I've got to remember that set of parentheses, x plus delta x. That right there will create probably the number one problem if you miss this, because you think, oh, these cross out, and then you just write x plus delta x without the set of parentheses. But the reason you need it, is because of that minus sign. Because minus sign in front of a set of parentheses means goes through and changes the sign, right? Okay, but again, my fraction was gone, which is what we wanted. I am not going to distribute anything here, all right, on that bottom. I'm going to rewrite. I'm going to put my x first, and then I'm going to do the delta x, and then I'm going to do the x plus delta x. That's just personal preference. If I would have wrote delta x, that would have looked a little confusing. By doing the x first and then the delta x, we realize it's an x term, it's a delta x term. Okay. All right, now distribute or go through and change the signs. Distribute a -1 there on top. Okay, I'm going to go ahead and go across, I think, at this one. The limit as delta x approaches 0. That's going to be an x minus a delta x. And then I've got an x, delta x, x plus delta x on the bottom. Okay, so we ought to be able to cross out a bunch of stuff. X minus x, that's going to go away. I've got a delta x in the top with a negative sign in front and a delta x in the bottom, so my delta x's are going to go away, but then there's a negative right there, so I still have a -1 in the top. Okay, so I'm going to clean that up just so I've got something to look at here that's neater. The limit as delta x approaches 0, I've got -1 on top. I've got an x plus delta x on the bottom. And then ready for my direct substitution because I've simplified all I can. So I'm going to do my direct substitution. All right, I'm going to replace delta x with 0. Okay, so then I'm going to have a -1 on top. I'm going to have an x plus 0, which basically makes the denominator that x times x squared. Yeah, because we're adding there. So -1 over an x squared. And then we're pretty much good to go there. Now, in all honesty, really, the only calculus we did in there, I mean, writing the limit notation in front of each step, I mean, the limit notation, there's your calculus. But when I go from here to here and I do the direct substitution, that's the only calculus in that entire problem. All of this other stuff, when I multiplied through by the least common denominator, when I originally substituted the formula, that's algebra. When I multiplied through by the least common denominator, that's algebra. All this simplification is all algebra, okay? So we haven't really even got into a lot. But most of our calculus problems are going to be like that. We're going to do one thing of calculus, and then everything else is algebra.